Okay, hi guys, and this is where we left off last time, and today we are going to only talk about significant figures. So significant figures is one of those really important topics in chemistry, and it's one that's like a bit hard to grasp, but once you know the rules, it's pretty simple. By definition, significant figures are some numbers, some digits inside a number that express precise value. It might seem like a whole lot of words, but numbers from 1.9 are always significant. Always. Zeros depends on where they're put. Well, if you think about it, it's true. Numbers from 1.9 always express precise value. Zero, you might think it does, but that really depends on the definition for precise value. So basically, there are some rules that dictate should zeros be significant figures or not, depending on where they're put. And before I say anything, here's like a very simple why in some cases zeros are not significant figures. If we've got like 1,000, there's only one significant figure, which is the 1 here. But what if the measurement is in meters? Like, if you say the whole thing, all 4 digits are significant figures, and what if the measurement is in meters? This is equal to 1 kilometer, is it not? Yeah. So these zeros are just gone, literally. But, like, if there's a decimal point here, this is not one of those like commas. This is a decimal point. All 4 are. Because like if you think about it, for example, if this is a measurement in kilometers, 1 kilometer, this is gonna be 1,000 meters. So all the zeros afterwards are gonna be used. But this might be tricky when you are tackling real problems, and it gave me some problems. So our chemistry teacher didn't really like explain it that clearly. This is as far as she went. But then I watched the YouTube video, and yeah, I got the hang of it. So basically, it's dependent on rules. Let's say there's some zeros that are between other digits. These zeros are always significant figures because it makes sense, right? They always express precise value. They're part of this whole bundle of numbers. And zeros before the whole bundle of non-zero digits, zeros before that are always not significant figures. So we've got 0.01004. These are the significant figures. These are not. So basically, what I mean by a bundle of numbers, and this is, well, not, I don't think it's mentioned by anyone like before, and this is like my personal way of remembering this. A bundle of numbers starts with a non-zero number and ends with a non-zero number. Well, what you might ask, what about this? The 1 is the bundle of numbers. It's just one single digit. Well, I guess I should call it the bundle of digits, but yeah, you get the idea. Anyways, in this case, this is the bundle of numbers, because later, it actually took me some time to develop this concept, but once you got it, it will really help you a lot in significant figures. So zeros before the bundle of numbers never counts. Zeros after the bundle of numbers, which is like this, well, the lag is real. Zeros afterwards, in this case, only the bundle of numbers counts. Oh, by the way, the bundle of numbers is always, the bundle of digits. Well, you get the idea. So the bundle of digits are always significant figures. So 4 Yep. Oh, by the way, in those cases where zeros are sandwiched between like two numbers, the whole thing is just one big bundle of numbers. Here we have, here the only the bundle of numbers is significant. These two zeros are not. And again, it's the same thing. Like I love to use the kilometer and meter conversion because it makes, I don't know, sounds right to me. And I also quite like the gram kilogram conversion. I don't know, sounds good. Anyways, zeros afterwards. Sometimes it counts, sometimes it does not. So now we should ask ourselves a big question: is there a decimal point? And by that, I don't mean a decimal point here. Well, this is one of the scenarios, but if this isn't a decimal point here, all of it is. And a decimal point practically anywhere in the number. Even if we've got the 0.00400. Seriously, the lag is real. Okay. So, I guess my machine is under some pressure because I'm running a lot of things, so there might be some lag. Like, after my little, pencil moved, would line appear, like, yeah. So that's a bit of lag. Anyways, in this case, zeros before never count. Zeros sandwiched always counts. Zeros between two numbers always counts. The bundle of numbers. In this case, the bundle of numbers is this. And there is a decimal point. There is a decimal point anywhere in the number. So there is a decimal point here. So these zeros count. And this is really a cool way to, get to know significant figures. And it really helped me a lot. But now you might be asking me, what are these things used for? Used for? And they're used actually for calculations. So for example, we've got two numbers. Say we have got this number here divided by say this number. And then the result, the number of significant figures in the result should be the same as the number of significant figures in the number that has the least significant figures. What I mean by that, so there are two numbers here. Which number has the least significant figures? 2, right? And so the answer must also have, 2 has one significant figure, the digit 2. So the answer must also have only one significant figure. In this case, I think it's 0.57, but I am horrible at, I'm an idiot. 0.52. Okay. So, like I said, I'm horrible at calculations. So, the answer should be 0.5. The lag is real. 52. So, 2 significant figures. Only one is needed. And, in this case, we can approximate and just go 0.5. So, we don't have one significant figure. Another way to get rid of significant figures is, for example, if I have the 0, actually let me do 10.0. We've got 3 significant figures, but we only want one significant figure. So we can do 1. Actually let me just do it 2 here. So we can do 2 times 10 to the power of 1. In this case, if we want one significant figure, we can also go just 20, one significant figure. But this is just another way using scientific notation. So it's pretty cool. I still haven't felt the usefulness of this. I know it can save us a lot of work, but it isn't that useful to me. But later, uh, especially in calculating moles, it'll become more and more useful. Even though I never felt that it was like such an essential thing, like the mole, not the animal though, the other thing, the unit, the mole. It's still pretty useful. I still quite like it, and teachers seems to love using this as test questions. But hopefully you get all of them correct, and those test questions just give you points. So yeah, why not? So that's all for today, and see you next time.